So look at the first one. Express sine of x minus cos of x in the form r sine x minus alpha, where r is a positive constant. So that means that r is greater than 0. And also that 0 is less than or equal to alpha, which is less than or equal to pi on 2. So that means I am in my first quadrant. Okay, so we need it in the form of r sine of x minus alpha. So we are going to go to our formula sheets and look at our sum and difference formulas. Okay, so what we're going to do is we're going to rewrite this sine of x minus alpha. And on your formula sheet, you'll see that that is equal to sine of x cos of alpha minus cos of x sine of alpha. The next step was to bring that r in, so expand your brackets. So on our left-hand side, we have what they want us to express in terms of this. So we have our sine of x minus our cos of x. So now we're up to equating our coefficients. So in front of our sine of x, we have nothing. Well, we do. We have 1. Okay, and in front of our cos of x, same. We have, this time, -1. So equating our sine, okay, on the left-hand side, we have 1 equals, and on the right-hand side, I have r cos of alpha. Now looking at our equating our cos coefficients. So on the left-hand side, I have -1. Now make sure you don't miss that negative. And on the right-hand side, I have equals negative r sine of alpha. So I've got R1 equals R cos of alpha, equation 1, and getting rid of the negatives because there's negative on both sides, we have 1 equals R sine of alpha as my equation 2. Now I recommend what you do now is you look at r squared first. So we're going to go equation 1 squared plus equation 2 squared. So I've got r squared sine squared alpha plus r squared cos squared alpha equals 1 squared plus 1 squared. Bring my r squareds out. I get sine squared alpha plus cos squared alpha equals, on my right hand side, 1 plus 1 is 2. We know that sine squared alpha plus cos squared alpha equals 1. So I now have that r squared equals 2. So r is the square root of 2. Now I'm going to do this off to the side. I'm going to go equation 2 divided by equation 1. So now I have r sine alpha over r cos alpha equals 1 over 1. So tan alpha equals 1. I need to now work out what my alpha is. My reference angle for tan of alpha equaling 1, or would be tan to the minus 1 of 1, which is pi on 4. The other thing to note, let's go back to equation 1 and equation 2. From equation 1, I have 1 equals r cos alpha, and I've worked out that r is the square root of 2. So 1 equals the square root of 2 cos of alpha. So 1 on root 2 equals cos of alpha. From equation 2, I have 1 equals r sine of alpha. So 1 equals the square root of 2 sine of alpha. So 1 on root 2 equals sine of alpha. So my cos of alpha is positive, my sine of alpha is positive, and my tan of alpha is positive. So I know I'm in my first quadrant. It also said it with the domain at the beginning. Okay, but that's just to explain that. So now let's plug in with what we started with. We said that r sine x minus alpha was equal to sine of x minus cos of x. That's what I started with. Therefore, we can write our sine of x minus cos of x has to equal my r, which is the square root of 2, sine x minus, and my alpha was pi on 4. And I need to actually write that. I said it, but I didn't write it, remembering our alpha is pi on 4. Now note, when we're looking at this, if we were looking at graphing it, we know that that's a sine curve. We know that the amplitude's root 2, and we know that it has a phase shift or a horizontal translation of pi on 4 to the right. There is no vertical translation. Another thing is I can use that to solve, which I'll do in another example later on. Okay. Oh, another thing I didn't mention with this graph though is it would have a period of 2 pi. So just to summarize that, my amplitude would be root 2. My period is 2 pi on d, and there is no d, so it's 2 pi. And my phase shift equals pi on 4 to the right. And I said there's no vertical shift. So you can see how this helps. Let's move on to another example. Here we have express cos of x minus the square root of 3 sine of x in the form of r cos x minus alpha. So let's start with that r cos x minus alpha. Looking at your formula sheet, you're looking for that cos of x minus alpha. So that's going to be cos of x cos of alpha plus sine of x sine of alpha. Okay, now we want to express cos of x minus the square root of 3 sine of x in this form. So expand out your brackets. You got r cos x cos alpha plus r sine x sine alpha. So this is a recipe that you need to learn. Equating the coefficients, our cos of x, remembering there is a 1 in front of it. So that means I have that r cos of alpha has to equal 1. That's my equation 1. Looking at our sine of x to equate that coefficient, we have the square root of negative the square root of 3, sorry, be really careful with the negative, I almost missed it. Negative square root of 3 equals r sine of alpha, and that's my equation 2. Now let's add and square our equations. So 1 squared plus 2 squared. I'll have r squared sine squared of alpha plus r squared cos squared of alpha is going to equal negative root 3 all squared plus 1 squared. So r squared all outside of sine squared alpha plus cos squared alpha is going to equal negative square root of 3 all squared is 3 plus 1 squared is 1. We know our identity is that sine squared alpha plus cos squared alpha equals 1. So we have r squared equals 4, so our r has to be 2. And we'll take the positive value for it. 2 divided by 1, so equation 2 divided by equation 1, we're going to have r sine alpha over r cos alpha equals negative root 3 over 1. So tan alpha equals negative root 3. Our reference angle would be inverse tan of root 3, and that is pi on 3. Now, think about what we've got. For equation 1, we have r cos alpha equals 1. So that means 2 cos alpha equals 1. cos of alpha equals 1 on 2. From equation 2, we have negative root 3 equals 2, or write it the same way, equals r sine alpha. So negative root 3 equals 2 sine alpha. So negative root 3 on 2 is sine of alpha. Okay, so we have that sine is negative, tan is negative, and cos is positive. That means we have to be in our fourth quadrant. So coming back to here, our alpha has to be negative pi on 3, being in our fourth quadrant. So our cos x minus root 3 sine of x, which was equal to r cos of x minus alpha, and I'm running out of room, so I'm going to work across, which you shouldn't do, you should work down, but it's going to be equal to, my r was 2, so 2 cos x. Now my alpha is minus pi on 3, so minus pi on 3 becomes plus pi on 3. Right? So now let's move to the next bit. It says, hence find the range of the function f with rule f of x equals cos of x minus root 3 sine of x, and find the maximum and minimum values. So we have that our f of x is 2 cos x plus pi on 3. My amplitude of this function equals 2. So therefore, my range is from negative 2 to 2. My minimum value is going to be negative 2. And my maximum value, remember it says maximum values of f, so it's not a coordinate, just minimum and maximum. My maximum is going to be 2. Now there's one more part to this question, and I've put on a new page so I could spread out the part A. So it says solve cos of x minus the square root of 3 sine of x equals 1. So we found out that all of this was 2 cos of x plus pi on 3. So that means we have 2 cos of x plus pi on 3 equals 1. Divide both sides by 2. I get cos of x plus pi on 3 equals 1 on 2. Now, I also have a domain. My domain is at 0 is less than and equal to x, which is less than and equal to 2 pi. I'm dealing with x plus pi on 3, so I have to change my domain. So I add pi on 3 to both sides. And I'm going to leave that like that rather than change it because it's not a final answer. So my reference angle is going to equal inverse cos of a half, and that is pi on 3. Now, cos is positive a half, so we know we're in our first and our fourth quadrant. So our x plus pi on 3 is going to be in our first quadrant, pi on 3. In our fourth quadrant, it's going to be 2 pi minus pi on 3. Now, going back to our domain, it has it says that we need to start at pi on 3, which we do, so that's fine, but it has 2 pi plus pi on 3. So that means I can go around again for that pi on 3. So 2 pi plus pi on 3. So that's another rotation. So now I have x plus pi on 3 equals pi on 3. 2 pi is 6 pi on 3. 6 pi on 3 minus pi on 3 is 5 pi on 3. 2 pi is 6 pi on 3 plus pi on 3 is 7 pi on 3. Now I need to get rid of this pi on 3 on my left-hand side, so I need to take pi on 3 away from each of these angles. So my x is pi on 3 minus pi on 3 is 0. 5 pi on 3 minus pi on 3 is 4 pi on 3. 7 pi on 3 minus pi on 3 is 6 pi on 3. And I need to realise that I can simplify that last angle. 6 pi on 3 is 2 pi. And that fits in my original domain, which was 0 to 2 pi. So always check that as well.